talking about, I'll stand over here, animacy and word order choice in an artificial language learning experiment. So this is work I've done with my supervisors at the Centre for Language Evolution at Edinburgh University. So why are we interested in animacy? Well, the relationship between animacy and syntactic structure has been well documented and well studied in typological studies and language production studies. So one example of this, for instance, is differential object marking systems, which are often based on animacy distinctions. And there have also been a whole load of studies that have, language production studies, that have found that when people describe events or scenarios, animate entities tend to be assigned more prominent positions than inanimate entities. So they tend to be mentioned first or earlier, or they're more likely to be assigned a subject role. And of particular interest in my own work is findings from a number of studies that have found that in emerging sign languages, animacy distinctions have an influence on word order choices. And so it's likely then that animacy distinctions play a key role in the emergence and evolution of word order conventions and preferences in emerging languages. So there's been, in recent years, quite a few studies have used the silent gesture paradigm to investigate exactly how word order is influenced by animacy. And for anyone who doesn't know, in silent gesture, people describe an event, say, using only gestures and no speech, and so they're not constrained by the conventions of their native language. So in today's talk, I'm going to focus on two studies in particular, so Gibson and Meyer, and I'm going to talk about two competing hypotheses that have been proposed to account for the different results that have come out of this work. I'll then go on to talk about an artificial language learning study where we tested these two hypotheses. So starting with the Gibson study from 2013. So in this study, they recruited English, Japanese, and Korean speakers, and they asked them to describe using gesture a series of non-reversible and reversible events. So non-reversible events, for example this one, only have one plausible interpretation. So if we don't share a word order convention for indicating participant roles, and I say woman star kiss, you know that it's the woman kissing the star and not vice versa. But reversible events are potentially ambiguous. They have more than one plausible interpretation. So if I say man, boy, push, you don't know if it's the man pushing or the man being pushed. So you don't know what the participant roles are. So what they found in this study was that when people describe non-reversible events, they typically express the object before the verb. So the authors class these as SOV responses. For reversible events, the results were a bit more mixed. So the English speakers typically expressed the verb before the object, and these were classed as SVO responses. But the Japanese and Korean speakers, just like non-reversible events, expressed typically the object before the verb. So to explain the English speakers' preference for SVO when describing reversible events, Gibson and colleagues proposed the noisy channel hypothesis. So this is an information theoretic account, and it's based on the notion that communication takes place across a noisy channel. So what they argue is that SVO, or more generally verb medial orders, are more robust against information loss when talking about reversible events. So how this works then, suppose the sender wants to convey a message about a girl kicking a boy, and let's say one of these nouns is lost in transmission, so the girl, so the receiver only receives boy kick. In this case, they won't be able to determine if the boy is the agent or the patient because both entities appear on the same side of the verb. According to Gibson and colleagues, placing the verb between the agent and the patient can avoid this ambiguity. So if the receiver receives kick boy, in this case they'll be able to determine that the boy is a patient, so part of the message has been recovered. So that's good for the receiver, but they also claim that the same principle benefits the sender. So what they say is that it applies even if there's only one individual who's encoding an event meaning for him or herself, verb medial orders maximize recoverability, so even if there's no communication. So that's the noisy channel hypothesis. In the Meyer study, they also recruited participants from different groups, so Hebrew speakers, Turkish and Arabic. But in this study, they also looked at the signed responses from signers of ISL, ABSL and KQSL, and these are all relatively young and emerging sign languages. So again, what they found was for non-reversible events, there was a preference for SOV order across all groups. And again, they found a more varied picture for reversible events. So some groups, in particular the Hebrew speakers and ISL signers who are literate in Hebrew, they typically described reversible events using SVO. And other groups, in particular the non-literate signers, typically used SOV and OSV in roughly equal proportions. So to explain these results, so what they suggest is that the SVO preference for reversible events, well, that can be described by interference from another language. But to explain the roughly equal preference for SOV and OSV, they propose what I'm calling the cognitive saliency hypothesis. This is not their term, it's mine. It's based on two principles. So the first is the human first principle. And this is basically just the idea that human entities are in some way more salient than non-human entities, and so they tend to be mentioned first. And the other is the idea that concrete entities are more conceptually accessible, so more easily retrieved from memory than abstract relations, and so actions typically tend to be mentioned last. And so these two principles together can explain why, when the subject or the patient is human and the object is inanimate, SOV is preferred, and also why SOV and OSV are roughly equally preferred when both are human. So these two hypotheses, noisy channel and cognitive saliency, they make different predictions about how people should describe events given certain restrictions on the word orders that they're able to use. So more specifically, if a language always expresses the action in the final position, but it allows variable or flexible ordering of the agent and patient, so apologies, I'm now shifting into semantic roles, so it allows APV and PAV. The cognitive saliency hypothesis predicts that we should see roughly equal proportions of the two orders for reversible events, and predominantly APV for non-reversible events. The noisy channel hypothesis, according to that hypothesis, both of these orders are suboptimal for describing reversible events, and it actually makes no specific predictions about non-reversible events. So what we might expect is people just to randomise between the two orders, assuming no other biases or pressures are at play, and no conditioning on event type. If the language always expresses the patient in initial position, so it allows PVA and PAV, the cognitive saliency hypothesis predicts that we should overall see a preference for PAV because it expresses the action in final position. Noisy channel hypothesis says we should see a preference for PVA for reversible events, and again makes no specific predictions about non-reversible events. So to test these hypotheses, we ran 3 experiments, and these were all pre-registered on the Open Science Framework, and I'll talk about the design of these experiments as we go on. So we recruited participants using Amazon's Mechanical Turk, and we randomly assigned them to either a P first or a V final language. The language described a living concept, so here we have an example of a human, an object, and a kind of abstract representation of an action. And these are 2 examples of the events, so a reversible event on the left and a non-reversible event on the right. So we first trained participants on a lexicon. Bless you. We then trained them on the grammar, so there were multiple training phases. So in each phase they saw an equal number of reversible and non-reversible events, and each word order appeared an equal number of times. We also randomised the orientation of the event images across trials. So sometimes the agent was on the left, sometimes the agent was on the right. So in the final testing phase, participants were asked to describe a series of reversible and non-reversible events, and the 2 event types were just randomly mixed together by typing the responses using the novel language, and no feedback was given. So the first experiment then, so just as a reminder, this is the kind of overall pattern of responses predicted by each hypothesis for each language type. If we start with the V final language, so what we're looking at here is increasing proportion of PAV going up the y-axis. Each of the coloured lines represents an individual participant, and the dark line is the average responses. So what we found was that on average there was a roughly equal proportion of PAV and APV for reversible events, and slightly more APV for non-reversible events. But when we submitted this to a statistical analysis, there was no effective event type, so the differences weren't significant. In the P first language, we saw slightly more PVA for reversible events, but again, they weren't significant. So these results weren't consistent with either hypothesis. And one thing you might notice is that in both language types, there's quite a high proportion of people who always use a single order in all trials. So these people kind of at the extremes, the top and the bottom of the two plots. And in fact, what we found was that 50% of people in the P first language always used a single order on all trials, and in the V final language, that number was 39%. So why might this be? Well, one possibility is that the learning task was just too difficult. So there have been studies that have shown that the tendency to regularize across variants increases as the cognitive demands of the task increases. So people had 11 concepts to learn, they had a grammar rule in the space of about 10 or 15 minutes, I think the experiment lasted. So to address this, we designed a second experiment that was intended to make things easier for people. So we made two changes. Excuse me. The first was that we, instead of using a random lexicon, we used a more English-like lexicon. So some words had some kind of similarity to their English counterpart, so curler for girl. Other words had an element that had some kind of association with a reference, so legate for kick. The second, more important change we made was that we eliminated grammar training altogether. That sounds weird, but it's not as weird as it sounds. So that means that in the final testing phase, what we did was we presented participants with a partially completed description. So we provided the constituent that was always fixed. So it was either P in the initial position or V in the action in the final position, depending on the language type they'd been assigned to. And so all they had to do was to complete the description using the vocabulary that they'd been trained on. We also implemented a filtering criterion, so only participants who learned the vocabulary well enough proceeded to the final testing phase. So these are the results. The first thing to notice is that the proportion of PAV was substantially lower than it was in the first experiment. The second thing to notice is that our manipulation didn't work, because actually the proportion of people using a single order in this experiment was much higher than it was in experiment 1. However, when we did our statistical analysis, we found no effect of event type in either language group. So again, these results weren't consistent with either hypothesis. After we'd run these experiments, though, one thing we realised was that although we had randomised the orientation of the image across trials, what we hadn't done in our pre-registered model was to account for any possible effects of image orientation, the joys of pre-registration. And so there have been some studies in language production that have shown that, for example, the passive construction is more common when the patient appears on the left-hand side of an image. So when we looked to see if something similar might be happening in our own data, we found that there was. So in the V final language, people were significantly more likely to express the patient first when it appeared on the left-hand side of the image, and that effect was really strong. We didn't find any effect in the P first language, which is maybe not surprising because the ordering of the agent and the patient was fixed. And this is potentially really problematic for our study, because if people are relying on the orientation of the image, so effectively just reading left to right as though it were text, then any tendency to condition on event type might just be overridden. So we designed a third study, and this was designed to completely eliminate any tendency to rely on the orientation of the image. So what we did was, instead of presenting static event images, we presented the images rotating around the y-axis, and the image disappeared after a while. So to see what that looks like, so the image faded in, it rotated around the y-axis, and then it faded out after 4 seconds, and then people were asked to describe what they had seen, or complete the description of what they had seen. So these are the results. So they look very similar to what we found in experiment 2, but this time we did find an effective event type in the V final language. Just looking at the average responses, it doesn't appear like there's much going on, but if you look at the coloured lines, so 16 participants varied their word order. We still had quite a lot of people using just a single order, and of those 16, 12 people used PAV more for reversible than they did for non-reversible events. Again, we found no effect of event type in the P first language. So the final thing we did was we conducted a post hoc analysis of the data combined from all 3 experiments. This was a model we used to analyse the data, so this time we did include orientation. We had to have some kind of proxy for orientation in the third experiment. So what we found was in the V-final language, there was overall a significant main effective event type. But what we didn't find was any evidence to support one of the main hypotheses, one of the main predictions rather, of the cognitive saliency hypothesis, which was that people should produce APV and PAV in roughly equal proportion for reversible events. Instead, what we found was that overall, on average, there was a preference for APV. In the P first group, there was no effective event type. And again, you'll remember, hopefully you'll remember that one of the other predictions of the cognitive saliency hypothesis was that in the P first language, people should overall prefer PAV. In fact, what we found was an overall preference for PVA. So I'll say more about these overall preferences in the last slide, or the next slide, sorry. So what do these results tell us about these two hypotheses, and do they say anything about word order and animacy more broadly in emerging languages? Well, what we conclude was that evidence from the V-final language did partially support the cognitive saliency hypothesis. So we did see that PAV was more frequent for reversible events compared with non-reversible events. And what we suggest is that the deviations from the predicted results could be down to interference from the participant's native language. So APV may have been the preferred word order in the V-final language because it expresses the agent before the patient, and that's consistent with canonical English word order. PVA might have been preferred overall in the P first language because it's analogous to the English passive construction, which follows this overall pattern. So what this suggests then, so these results and evidence also from emerging sign language suggests that word order in emerging languages is a function of what's salient to the producer. So producers are not necessarily using word order to convey information about agents and patients. In terms of the noisy channel hypothesis, we found no evidence that verb medial orders were preferred at all for reversible events, so our data didn't support this hypothesis. However, a caveat to that is that we don't want to rule out the possibility that communication does have some role to play. It probably does, but we do need to do more work to understand how people, during interaction, during communication, negotiate this ambiguity and if and how this influences word order choices. So these are the overall conclusions, and thanks for listening.